Did you know that honey is the only food in the world that can be eaten even after thousands of years? It's an astonishing fact that honey discovered in ancient Egyptian pyramids and tombs dating back to 3000 BC was still edible even today. So, why is it that only honey can maintain its quality without spoiling for such an incredibly long time? Today, we're going to uncover its scientific secrets. First, what exactly is spoilage? It primarily occurs when microorganisms multiply and break down food components. For food to spoil, microorganisms need conditions where they can survive and reproduce. These include moisture, nutrients, appropriate temperature, and acidity. However, honey cleverly and naturally fails to meet several of these conditions. The key lies in honey's unique composition and structure. Honey's main component, making up about 80%, is sugar, primarily composed of fructose and glucose. In addition to this, water accounts for about 20%. This incredibly low water content is the first step in honey's secret to not spoiling. It creates an environment completely different from ordinary foods. For microorganisms to survive, a certain amount of water is essential. Honey, however, makes this water difficult for them to utilize. A crucial concept here is water activity, which is a numerical measure of the amount of free water in food. Microorganisms can generally thrive in environments with a water activity of 0.85 or higher. Below this, reproduction becomes extremely difficult. So, what's the water activity of honey? It's an astonishingly low average of 0.6 or less. This is even lower than dry fruits or dried fish, which are already known for their very low water activity. This extremely low water activity creates a desert-like environment for microorganisms. Without water, they can't survive, right? When microorganisms lose water from their cells, they stop functioning and eventually die. Honey utilizes this principle. When bees collect flower nectar, they bring it back to the hive and evaporate the water from the nectar by fanning their wings and regurgitating it. In doing so, they condense the water content from about 80% in the original flower nectar to about 20% in honey. This concentration process is crucial. This dehydration effect, which removes water, is honey's first and most powerful barrier against microorganisms. Significantly contributing to low water activity is honey's high sugar content. This high concentration, with about 80% being sugar, creates another powerful effect. That is osmotic pressure. When liquids of different concentrations are separated by a semi-permeable membrane, water moves from the less concentrated side to the more concentrated side. Microbial cells also have semi-permeable membranes. In the ultra-high concentration liquid that is honey, water from inside the microbial cells is drawn out. This is the same principle as using salt when making pickles. It's very similar to how salt draws out moisture from food ingredients and prevents spoilage. Salt curing and sugaring are used for long-term food preservation precisely because they utilize this dehydrating effect of osmotic pressure. In the case of honey, its overwhelming sugar concentration creates an environment where absolutely no moisture remains for microorganisms to thrive. The osmotic pressure from high sugar content, combined with low water activity, becomes a powerful preservation mechanism, truly a death trap for microorganisms. Another characteristic of honey is its strong acidity. Generally, honey's pH value is said to be around 3.2 to 4.5. A low pH, meaning a highly acidic environment, is one where many microorganisms struggle to function or cannot survive at all. Just as human stomach acid kills bacteria that enter with food, honey's acidity suppresses any potential bacteria lurking within it. Many bacteria that cause food poisoning, in particular, cannot multiply in highly acidic environments. For example, even Clostridium botulinum cannot grow in honey. However, caution is needed for infants, because an infant's intestinal environment is underdeveloped. In extremely rare cases, botulinum spores can multiply. This is also one of the preservative mechanisms that bees naturally acquire during the process of transforming flower nectar into honey. Low water activity, osmotic pressure from high sugar content, and strong acidity. These physical and chemical properties work in combination to prevent honey from spoiling. Furthermore, honey has another secret weapon added by bees: the power of enzymes. When bees ingest flower nectar, they add an enzyme called glucose oxidase from their salivary glands before bringing it back to the hive. This enzyme reacts with the glucose and tiny amounts of water in the honey, triggering a chemical change. As a result, substances called gluconic acid and, even more importantly, hydrogen peroxide are generated. Hearing hydrogen peroxide might ring a bell for some of you. That's right, it's a powerful antiseptic compound also used in disinfectants. Although present in very small amounts in honey, this hydrogen peroxide further inhibits the activity of any microorganisms that might have survived, exerting a bactericidal effect. Bees, using their own bodily mechanisms, create a perfect preservative food to ensure their own food-source honey doesn't spoil. This truly is a miraculous preservation mechanism created by nature. It's a testament to the wisdom and evolution of bees. So, how should you store such a miraculous food like honey? Basically, nothing special is required. The important thing is to store it in an airtight container, away from direct sunlight, at room temperature. Putting it in the refrigerator makes it more prone to crystallization. Crystallization doesn't mean the honey has gone bad. It's a natural phenomenon caused by temperature changes and the glucose ratio, and it doesn't affect the quality. You can return it to its liquid state by warming it in a hot water bath. However, be careful not to make it too hot, as high temperatures can potentially damage nutrients and flavor. While honey doesn't spoil, its flavor can diminish over time. To enjoy it at its best, it's recommended to consume it relatively quickly after opening. Today, we've unraveled the amazing secret of why honey doesn't spoil even after thousands of years. Low water activity, osmotic pressure from high sugar content, strong acidity, and the generation of hydrogen peroxide by enzymes added by bees. These combined elements completely inhibit the survival and reproduction of microorganisms, making honey the most perfect natural preservative food on Earth. This sweet miracle, created by tiny bees, is packed with profound natural wisdom that we can learn from. Next time, let's continue to delve into the amazing science hidden in our everyday lives. If you found this video interesting, please give it a thumbs up and subscribe to the channel.